In section 8.3, we're going to talk about inverse trig functions. So before we dive into that, let's think about something we already know. Every mathematical operation has another operation that undoes it. So for example, addition. To undo addition, we would use subtraction. Those two cancel each other out. Multiplication gets undone by division. Squaring a number gets undone by a square root. So if you have something like this and you need to solve it, you can square root both sides. That undoes it and you end up with x equals 3. Trig functions also have something that undo them, and it's called an inverse trig function. We have 3 of them. We have the inverse sine, which looks like this. We have the inverse cosine, which looks like this, and the inverse tangent, which looks like this. And if you look on your calculator right above sine, cosine, and tangent, you see the inverse sine, inverse cosine, and inverse tangent. So, when to use trig functions versus when to use inverse trig functions. So we use sine, cosine, and tangent when we are finding a side length. We've already done this. We spent a couple days on it. Those were the task parts that we did. And you use the inverse trig functions when you are finding an angle measure. So the only time you would use this is if you are looking for what angle A is or angle B is. So let's say we have this triangle here. Our right angle would be right here. And it says if the sine of angle A is 3/4, find the measure of angle A. So let's label our triangle. Let's do A, B, C. The information they tell us is that the sine of angle A is 3/4. So sine, if we're talking about angle A, remember is opposite over hypotenuse. So we have this triangle here. It doesn't really matter what the other side is because we don't need it. But what we're going to do is we're going to figure out how big this angle is. Now what we need to do is we need to get rid of this sine here. We need to cancel it out. So what we're going to do is we're going to take the inverse sine of both sides. And what happens here is just like multiplication undoes addition, these get crossed off and we're left with this. And then it's just a calculator problem. We need to type in the inverse sine of 3 divided by 4. And whatever this spits out is going to be our angle. So for most calculators, you're going to have to hit the second button and then sine, and it'll give you inverse sine. Type in 3 divided by 4, and it spits out 48.6. And this is 48.6 degrees. And that's it. So what we're going to do for most of the problems I give you is you're going to be asked to solve a triangle. Now in order to solve a triangle, you need to find all the missing sides and all the missing angles. So before we actually do this one, let's just figure out what is missing. So if I asked you to solve this, you're going to have to find several things. First thing we need is angle J. So I have angle K, I have angle L is 90 degrees, and I need angle J. No trig should be involved for this, because if you have 2 angles of a triangle, you can always find the third. But then I'm also going to need side JL, we don't know this guy, and I'm going to need side LK, we don't know this guy. So there are 3 things that we need for this. Now we can use trig for some of them, we can use Pythagorean Theorem, and we can also use the Triangle Sum Theorem. So I want you guys to keep those possibilities in mind. We can use trig, we can use the Pythagorean Theorem, a squared plus b squared equals c squared, or we can use Triangle Sum Theorem, that all the angles in a triangle add up to 180 degrees. So using that knowledge, let's solve this triangle right here. So first figure out what you're missing. We need to find ST we need to find angle T, and we need to find angle R. Those are the three things we're going to need in order to be done with this problem. Now, ST is another side length, so we can find that with Pythagorean Theorem. So remember, you have A, B, and C is always your hypotenuse. So we would have ST squared equals, plus 5 squared equals 5.7 squared. So we end up here with 25. 5.7 squared gives us 32.49. And if I subtract 25, we end up with 7.49. And then if I take the square root of that, we get ST is 2.7. So that's one thing down. 2.7 is ST. Now we got to find some angles. This is where we're going to use the trig that we just learned. And it doesn't matter what angle you find first. So let's find T because I wrote it down first here. Now what I would do is take the sides that the problem gives you and use those rather than using the one that we found, just in case we did something wrong. So compared to angle T, they gave us the opposite side and the hypotenuse. So think back to SOHCAHTOA. Which trig function has opposite and hypotenuse? And it's sine. So we're going to make an equation. The sine of angle T equals the opposite divided by the hypotenuse. Now they tell us that the opposite is 5 and the hypotenuse is 5.7. Now this is the inverse trig that we just got done doing. I want to get T by itself, so I'm going to do the inverse sine on both sides. So this crosses off, and I'm going to type in the inverse sine of 5 divided by 5.7. And what this spits out is going to be my angle measure. So it tells me that T is about 61.3 degrees big. So once I know angle T is 61.3 degrees, I can use the Triangle Sum Theorem to find R, because 61.3 plus 90 plus R has to add up to 180 degrees. So if we do the math associated with this, we get the angle R is about 28.7 degrees. So we really only needed trig for one of these things here, but we solved the entire triangle. Let's do one more together. So for this one here, figure out what you need to know before you do any work. So we need angle B, we need side AB, and we need side AC. So for angle B, because I know these two angles here, I don't need to use any trig. You could use trig, but it's not necessary. I know that 53 degrees plus 90 degrees plus angle B have to add up to 180 degrees. So if I throw this in my calculator, I end up with angle B has to be 37 degrees. So there's one out of three things down. Now we got to find these two side lengths. So let's find AB first, because I wrote that down first. Let's make it X because we don't know it. Take the angle that they give you and do just what we did yesterday. They gave me the opposite side, and I got to find the hypotenuse. So in SOHCAHTOA, that would be sine. So sine of 53 equals the opposite divided by the hypotenuse. And you guys should be really good at solving these guys. We're going to cross multiply and get x times the sine of 53 equals 10. And if I divide both sides by the sine of 53, I end up with whatever my x equals. And then we can just throw this in the calculator. 10 divided by the sine of 53 equals 12.5. Now we have one more thing to solve for. We have AC. Now you can do this two different ways. You could use Pythagorean Theorem, or you could use Trig again. Doesn't really matter. Let's use Pythagorean Theorem because we haven't used that in a while. So this is what we don't know, this AC here. So we have AC squared plus 10 squared has to equal our hypotenuse, which we just said was 12.5. So we square that. This gives me 100. 12.5 squared gives me 156.25. If I subtract 100, this gives me 56.25. And then we got to take the square root. And you end up with 7.5. Now I want to show you if we use trig that this would have given us exactly the same thing. So let's go back to this and say that now this guy out here is my x. This is what I don't know. So compared to this angle, they gave me the opposite, and I got to find the adjacent. So SOHCAHTOA, I would be using tangent of 53 equals opposite over adjacent. If I cross multiply, I end up with 10 equals x times the tangent of 53. And if I divide both sides by the tangent of 53, I end up with x. And if you throw that in your calculator, 10 divided by the tangent of 53, we get x is 7.535540, blah, 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 blah. So you end up with exactly the same thing, whether you use Pythagorean Theorem or trig. It just depends on which one you prefer. So you have a worksheet that goes over some of this stuff. Give this a try. If you finish the worksheet, you have 2 new IXL that you can work on for a total of 6. And then you can work on any of the worksheets I've given you so far this week. Make sure you're asking questions about them. Monday we're going to review this week, and then Tuesday we'll take our quiz on this stuff. So make sure you're asking questions if you have them today, and enjoy your weekend.